Okay, page 3 and 4 of unit circle. So when you have a unit circle, we said that this could be like our Cartesian coordinate system with x and y. So basically you have +1 here, you have -1 here, you have +1 here, and -1 here. So this is the x-axis and this is the y-axis, right? So how can we find any coordinate, x comma y, along the unit circle uh, according to the angle theta? So if we have an angle theta here, we can actually use this triangle here, this theta triangle, to find these coordinates, because if you can see this side of the triangle is the x coordinate, right? And then this side of the triangle is the y coordinate. And if you look at this, this is actually equal to the adjacent side length, right? And then this is equal to the opposite side length. Okay, so we could say that the x coordinate here is the adjacent side of the triangle length, and the opposite side would be the y coordinate. Okay, now the adjacent side length over the hypotenuse would be cosine, right? But the hypotenuse is just 1 because the unit circle, the radius is 1. So let's say that instead of a comma o, we're going to have a divided by 1 and o comma divided by 1. And that's the same thing as a comma o, right? And then a over 1 is actually a over the hypotenuse. And o over 1 is actually opposite over hypotenuse. And so that's actually equal to the definition of cosine theta and sine theta. Okay? So cosine theta is actually the x coordinate of P, and sine theta is the y coordinate of P if P is a point on the unit circle that can be found using the angle theta. Okay, and the other thing is cosine squared plus sine squared is, let's see, if we look at this triangle here that we just drew, the purple triangle, okay, we have the adjacent, opposite, and hypotenuse. So using Pythagorean's theorem, adjacent squared plus opposite squared is equal to the hypotenuse squared. Okay, now let's divide everything by hypotenuse squared. So then we'll have adjacent squared over hypotenuse squared plus opposite squared over hypotenuse squared is equal to 1. This is equal to cosine squared theta. This is equal to sine squared theta, and that's equal to 1. So cosine squared plus sine squared is equal to 1. Okay, that kind of is an extension of Pythagorean's theorem. Okay, explain what all silly turtles crawl helps us to remember. This is just a silly mnemonic where A is all trig functions are positive in the first quadrant. So when you have the unit circle, in the first quadrant, both sine, cosine, and tangent all give you positive values. Okay? Now in the second quadrant, only sine is positive. Only sine positive. And then in the third quadrant, only tangent is positive. Everything else is negative. And in the fourth quadrant, only cosine is positive. Sine and tangent are both negative. Okay, so it's just a way of remembering what's positive and what's negative. Okay? Now let's fill out this table here using this mnemonic. Okay, so in quadrant 1, cosine is positive, sine is positive, and tangent is positive because all trig functions are positive. Second quadrant, we're talking about the degree measure of 90 degrees to 180 degrees. The radian measure is pi over 2 to pi. And only sign is positive, so we'll positive, negative, negative. Okay. Now the third quadrant, only tangent is positive. Only tangent is positive. Okay, and in the fourth quadrant, only cosine is positive. Cosine, negative, negative. Okay, and then the radian measures, you just do multiples of 90 degrees here. So this would be 270. This would be 270 to 360. This would be pi to 3 halves pi. 3 half pi. 3 half pi to 2 pi. Okay. For theta and radians and k from the set of integers, so k is an integer, it says that cosine theta plus 2 pi k equals cosine theta, and sine theta plus 2k pi is equal to sine theta. All this means is that if you have the unit circle, and let's say that you have a measurement theta, let's say this is the measurement theta. If you add 2 pi, any multiple of 2 pi, basically what you're doing is saying, hey, I'm going to add another 360 degree revolution on there. So basically you're back to where you started from. So adding 2k pi, which is any multiple of 2 pi or any multiple of 360 degrees, you're just getting back to the exact same angle theta. So obviously you're going to get the exact same thing you got back before. Okay, so multiplying or adding to theta any multiple of 360 degrees, you're just going to get the exact same value of sine or cosine. Okay? All right, so let's move on. For each unit circle illustrated, state the exact coordinates of the point A, B, and C in terms of sine and cosine. Use your calculator to give the coordinates of A, B, and C correct to 3 significant figures. Okay, so let's see. We have the unit circle drawn here. And let's see. A is 26 degrees is theta. B is 146 degrees. And C is 199 degrees. Okay? And then we're just going to use our calculator to find the coordinates. Okay. Oh, and first it says state the exact coordinates of the points in terms of sine and cosine. That's just, you just write it as, oh, this would be cosine 26 degrees, and then sine 26 degrees. This would be cosine 146 degrees, and sine 146 degrees. If they say to find it exactly, the only option is to leave it in terms of, you know, cosine and sine, because these are not angles, like special angles like 30, 60, 45, which might give you numbers that are whole numbers. These are just any old angles, okay? So how would you do this on the calculator? I'll show you how to do one, and then the rest of them will be easy, okay? So first thing you want to do is you want to make sure your calculator is in degree mode. So you go to mode, and then look, we're not in degree mode. Actually, the default is radians, I think, so you need to change it to degrees. When you want it to be degrees, you get out of mode by second quit. Then you say, oh, I'd like to know the sine of 26, for example. I'd like to know the cosine of 26, for example. Okay, so like, for example, the first one would be 0.899, and the second one would be 0.438. Okay, so that's all you have to do. You just put sine and cosine in exactly as written here in your calculator, and that will give you the points for 2. Now, with the aid of a unit circle, complete the following table. Now, you've already done this with the exploration. In fact, you've done more points than this, but you just use your, you remember that little sliver of a triangle I gave you? You're going to use that one, okay? So I'm going to make it a little bit bigger here. Okay, there's the sliver of the triangle. The sliver of the triangle can also be put on its side. Okay, like that. Basically, you have length 1, you have length 1, length 0. Theta here is like 90 degrees. Okay, 90 degrees. This is also 90 degrees. And this is 0 degrees. Okay, this would be 0 degrees, 90 degrees, 90 degrees, 1, 1, 0. Okay, it's a flat triangle. Okay, so at 0 degrees, it's 0 radians. At 90 degrees, it's, well, maybe we don't remember what that is, but 360 degrees we know is 2 pi. 180 degrees we know is pi. So these are just halfway in between. So this would be 3/2 pi. This would be pi over 2. Okay, what's the sine of 0? Well, let's look at this triangle here. If it's a 0-degree triangle, it would look really flat like this. The opposite over the adjacent would be the opposite over, the opposite over the hypotenuse would be 0 over 1. That's 0, right? Now the cosine here would be the adjacent over the hypotenuse, which would be 1 over 1, so that would be just 1. And the tangent would be the opposite over the adjacent. It would be 0 over 1, which is 0. Okay? And then we would continue doing that. Like now with 90 degrees, we'd look at this triangle. Sine would be the opposite over the hypotenuse, which would be 1. Cosine would be the adjacent over the hypotenuse, which would be 0 over 1. The tangent would be opposite over the adjacent, which is 1 over 0, which is infinity. Okay, and then 180 degrees would be, the flat triangle on the other side. Okay, so the sine here would just be 0 also. And the cosine would be a -1 because the adjacent would be -1 and the hypotenuse would be 1. So that would be -1. The tangent would be the opposite over the adjacent, so it would be just 0. Now 270 degrees would just be, the triangle like that. Okay, and then the sine would just be, -1. Cosine would be 0, and tangent would be the opposite over the adjacent. The opposite is -1. The adjacent is 0, so it would be -infinity. 360 degrees is actually the same as 0 degrees. It's the same angle, right? So everything is just repeated there. Okay? All right. Number 3, use your calculator to evaluate 1 over square root of 2 and square root of 3 over 2. 1 over square root of 2 is about 0.707. Remember, square root of 2 is like 1.414 or something, so my physics teacher used to always say that this was his favorite airplane, the 707. I don't even know if that exists. Square root of 3 over 2. Now remember, square root of 3 is about 1.7 or so. When you divide by 2, you get like 0.866 or something like that. But okay, I don't remember exactly. Let's do that one. Square root of 3. Square root of 3 divided by 2. Remember, you need to press the arrow there. 0.866. Yeah. Okay. Copy and complete the following table. Use your calculator to evaluate the trigonometric ratios, and then then an A to write them exactly. Okay. So I guess we want to write them exactly, which means we want to write them in these forms. Okay. Now remember, to write the radians, you can use your investigation. Okay. So it'd be pi over 6 here, pi over 3 here. 45 degrees is pi over 4. 135 is 90 degrees plus 45, so that would be pi over 2 plus pi over 4, which would be 3/4 pi. 150 degrees is 30 degrees short of 180. That would be So like 5/6 pi. 240 degrees. 240 degrees is 60 degrees more than 180 degrees. So that would be pi over 3 plus pi, so that would be 4/3 pi. 315 degrees is, let's see, it's about 45 degrees short of 360. So that would be, 2 pi minus pi over 4, which would be 7/4 pi, something like that. Okay. Now the sine of 30 degrees is 1/2. And the cosine of 30 degrees is square root of 3 over 2. Now I'm not going to go into how where you get the answers for these because this was the whole objective of the investigation. So I think you know, right? And then the tangent would be the opposite over the adjacent. It would be 1 over the square root of 3. 45 degrees. So the sine is it okay if we write 1 over square root of 2? Yeah, 1 over square root of 2. Cosine 1 over square root of 2. And the tangent is just 1, right? Because in 45 degrees, the opposite over the adjacent is 1. 60 degrees. 60 degrees is kind of the opposite of this. So the square root of 3 of 2 is the sine. Cosine is 1 over 2. And the tangent is square root of 3 over 1. 3/4 pi. So 3/4 pi is, so like 45 degrees would be that angle, right? 135 degrees would be that angle, yeah. So 135 degrees, the sine is the same as 45 degrees, so it would be 1 over square root of 2. The cosine is just the negative of that because it's pointing in the left direction of the x-axis, right? This is going to be +1, this is going to be -1, okay? And the tangent is going to be the opposite over the adjacent, so it would be a positive over a negative. It would be a -1 instead of a +1. And then 150 degrees is, let's see, it's like a 30, 60, 90 triangle pointing that direction. So the sine is 1 over 2, positive. The cosine is going to be negative square root of 3 over 2. Okay. And the opposite over adjacent, or the tangent, is going to be -1 over square root of 3. Okay. 240 degrees is 4/3 pi, which is, a 30, 60, 90 triangle that is there. Okay, so we're like going almost to 270 degrees. So the sine would be negative square root of 3 over 2. The cosine would be -1/2. And the opposite over adjacent would be negative square root of 3 divided by -1. So it would just be negative, it would be positive square root of 3. 315 degrees. Do you see how I'm drawing the little triangles each time? That's the way I do it. I don't memorize these. Okay, so this would be a 45, 45, 90 triangle pointing that direction. The angle goes like almost all the way around. It's missing 45 degrees to get to a full 360. So the opposite over so this would be square root of 2, this would be square root of 2, and this would be 1. Actually, it's I did that a little bit funny. Let me draw it a little bit bigger. Okay, so this is 1. This is 1 over square root of 2, and this is 1 over square root of 2. This is positive 1 over square root of 2. This would be negative 1 over square root of 2 because it goes down, right? Okay, so the sine would be -1 over square root of 2. The cosine would be 1 over square root of 2. And the tangent would be opposite over adjacent, would be -1. Okay? All right, we finished that. Use your calculator to evaluate sine of 100, sine of 150, sine of 80, sine of 30, and you know how to do that, right? I don't need to show you how to do that. You just go sine. Make sure it's in degree mode. So when you do that with your calculator, you'll find out that the sine of 100 is 0.985. Sine of 80 is also 0.985. Sine of 150 is 0.5. Sine of 30 is also 0.5. And you can see that, hey, that's weird. 100 and 80 both have the same sign. Sine of 150 and sine of 30 both same sign. So we see a pattern here that the sine of 180 degrees minus theta is equal to the sine of theta, right? Sine of 100 degrees is equal to the sine of 180 minus 100, which is 80. Sine of 30 degrees is equal to 180 minus 30, which is 150. Why is that? Well, if you look at these two triangles here, I drew a theta triangle, and then I drew a 180 minus theta triangle here. So these two triangles actually both have the same pink length here. The opposite side of both triangles is the exact same, right? And the blue is the hypotenuse, which of course is, they're both 1. So you can see that both of the lengths, the pink lengths, are the same because they're like mirror images of each other. And they're also both pointing in the same direction. So the sine is going to be the same for both. Find the obtuse angle which has the negative cosine of 40 degrees, 19 degrees, pi over 5, 2 pi over 5. The obtuse angle which has the negative cosine of. So let's draw 40 degrees. 40 degrees is about like that. Okay? And then the cosine is going to be like this length here. And then it's over the hypotenuse, which is that length there. We want the negative cosine of that. So let's see. The negative cosine would be, let's say the pink would be negative. So it would be pointing in the negative direction, and then, of course, the hypotenuse would be the same. So we can see that this would be a mirror image of that one. So if this is 40 degrees, this would be 40 degrees, which means that the theta angle would be 180 minus 40, which would be 140 degrees. So this would be 140. 19 degrees would be like 180 minus 19. Pi over 5 would be oh my gosh. It would be pi minus pi over 5, which is equal to 4/5 pi. Okay, 2 pi over 5, that would be pi minus 2 pi over 5. So that would be 5 over 5 pi minus 2/5 pi is equal to 3/5 pi. Okay, okay. Copy and complete. All right, so I mean, basically, what this is saying is that, hey, when you have a mirror image angle like this, the cosine is going to be the negative of the original cosine. Okay. Copy and complete. Now this time, look at the notation here. Theta with C in the superscript. That means we're doing radians. So if we're doing radians, then we do need to change the mode to radians. There we go. And then we get out of here. And so let's say sine of 0.75 radians. It's equal to 612, or 682, 0.682. And then we want the cosine of the same thing, cosine of 0.75, 0.732. What about the cosine of negative 0.75? Cosine of negative 0.75. Same thing, 0.732. What about the sine of negative 0.75? So sine of negative 0.75. Negative 0.682. Negative 0.682. Okay, so you would go through and fill all these in, which I'm going to do right now. Okay, so as you start filling this in, you'll notice a pattern that, you know, the signs are giving you opposite inverses, right? And the cosines are giving you the same numbers. Okay, now let's see if this makes sense to our little triangle exercise. So if we have an angle theta, if we do a negative of that angle instead, so that would just flip it over that way. Does it make sense that the sine is suddenly negative? Yeah, it does, because like let's say that this is going to be like 0.8 and this is 1. Well, this is negative 0.8 and 1, right? So the sine makes sense that all of a sudden it's negative. What about the cosine? Well, like, yeah, the cosine, let's say that this is like 0.2. If the cosine is 0.2, and I'm not saying that these two go together, I'm just making it up. Cosine is 0.2, it's positive cosine 0.2 in both cases. So yeah, the cosine should not change. So what do you suspect is true from A for the general angle theta? Well, the sines for the inverse angle is inverse, right? It's a negative. Let's say it's a negative. It's a negative. And then cosines for the inverse angle is the same. Okay, so that's what we suspect.